Okay, so let's first review what we did on...
No.
Yes. Remember everything on one side.
No.
So I'm going to have to add the 9K,
No.
put it in descending order, set it equal to 0. Then I make my snowflake. 1K and 1K go on the upper wings, 14 on the top, 9 on the bottom. Two numbers that multiply to be 14, add to be 9. 2 and 7, sometimes they're pretty quick to find. 2 and 7, so this is K plus 2 equals 0, K plus 7 equals 0. Remember that it's your answer is K plus 2 for factored form, K plus 7, but because we're solving, we set them equal to 0. Again, we're using something called the zero product property. If this whole thing equals zeros, then one of the factors must equal 0. And so I can solve, I get K equals -2 and K equals -7. Okay? So that's our process that we go through. Keep in mind, if you're doing multiple choice, it'll show it up as -7, -2, or -2, -7. There's no real order to that necessarily. Sometimes there are going to be funny things that happen, like in number 2. Everything is over here on the right, and we're used to seeing everything on the left, but it's okay. It can be on the right. I just have to put it in order. And then another funny thing that happens here is I'm missing the end term. So I'll write that as plus 0 because I don't have a non-term. Also, this is kind of different. If I have a negative in front, I hate working with the negative in front. It doesn't go well with the snowflake method. So I'm going to take that and change the signs of everything. Oops, that's a minus. Change the signs of everything all across the board. Plus 0, -0, that doesn't matter. This is a minus here. +2 became -2. And then I'll make my snowflake. So it's X and X, 0 on top, -2 on the bottom. Two numbers that add to be 0, multiply to be -2. That means one of them has to be 0. So this is X plus 0 equals 0, and X minus 2 equals 0, because this would be X plus 0, X minus 2. Or I could write this as X times X minus 2 as well, because I don't need to write the plus 0 on that. But when I'm done, X is 0, and X is add 2. Again, I think you guys are pretty good at solving those like simple equations. So if I have a negative in front, change all the signs to the opposite signs. If I'm missing a number at the end, put a 0 in front of it. What if, however, the front number, because it goes ax squared plus bx plus c equals 0, what if the front number is greater than 1? Then I have to consider two different things. Either I can factor out a GCF, like this one, or I'm going to have like a number in front of the letter in the upper wing. We'll get to that one after we finish this one. So factoring out a GCF, I do the same thing, get everything on one side. So I bring the 12x over, I minus 12x, minus 18. I get a little sloppy, I save some steps sometimes. It was positive at 12x over here. I want it blended over here, so I do the opposite sign. I can just bring it over like that. Then I'll pull out a 6. So when I am done and I set up my answer, the 6 will be in front. But now I have x and x, -3, -2, two numbers that multiply to be -3, add to be -2. Anybody think they got them? +1, -3, you said? Yeah, that looks good. So this would be x plus 1, x minus 3. Then I'm going to set each of my factors equals 0. 6 equals 0, x plus 1 equals 0, x minus 3 equals 0. Well, 6 is never going to be 0, so I can eliminate that one. 6 can't equal 0. If this were 6x, 6x could equal 0 if x was 0, but this isn't. This is just 6, and 6 won't equal 0. But x plus 1 equals 0 when x is -1, so it's just the opposite sign. X minus 3 equals 0 when x is 3. So my two answers, again, if this were multiple choice, it would be -1 and +3 in those brackets. But you can leave your answers just like x equals and x equals. The problem is, though, that you cannot always factor out that front term. So in problem number 4, factoring out a GCF is not an option. This 3m is going to stay here. I'm still going to bring everything to one side. 3m squared minus 7m minus 40. It's +40 over here. Bring it over to the other side. I make it -40 equals 0. Remember, it's the opposite sign there. When I set up my snowflake, I've got to remember the 3 times the -40. That's going to throw us for a little bit of a loop, but don't forget that. So it's going to be -120 on top. It didn't show up in any of these other ones because the front number was always 1 in front of the x squared. This one has a 3. So it's going to be multiplied by that -40. It's also going to show up here. And when I have that number and I find my answer, I always have to make sure on one side I simplify. So -120 on top, -7 on the bottom. The other thing that happens when we deal with these numbers in front is we end up with a lot of bigger numbers. They're not going to be as quick as the previous 3. So I might have to put some stuff on the side and start to think, well, it's 1 and 120. I know that one of them has to be negative and one has to be positive. I know the bigger number has to be negative and the smaller number has to be positive to get -7. I know 1 and 120 isn't going to get me that. This is where my calculator comes in handy. I'll try 2 and 60, 3 and 40, blah, 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 all the way down. 8 and 15 worked. Excellent. Thank you. So -15, +8. The order that you put these in, you could put +8, -15. That part doesn't matter, but the negative has to go with the 15. Also, I notice at least one of these will be able to be reduced. And because 3 and 15 can both be divided by 3, I reduce that side. Sometimes both of them will be able to be reduced, but in this case it was just the left side. So my answer is m minus 5, 3m plus 8 equals 0. So my two equations are m minus 5 equals 0. That one's easy, m equals 5, because it's just the opposite sign. This one, not so easy. 3m plus 8 equals 0. I'm going to subtract 8 and divide by 3. Kind of an ugly answer, but we'll leave it like this. Leave it as an improper fraction. Later on, when we're graphing and we're going to use that, we'll write it a little bit differently, but right now, I'm going to leave it as an improper fraction. I don't need to go any further than that. It shouldn't be able to be reduced because it wasn't able to be reduced over here. So it's not going to be able to be reduced here. And therefore, we're going to be done. A shortcut trick is flip this and change the sign. But remove the M, obviously. Whereas this one's just the opposite of that value. We're going to go through 2 more of those together, and then I'll let you try a few on your own. So 2 more together, I'll let you try a few on your own. Then when we move on, we're just going to practice this until we get pretty good at it, and then we're going to use it to graph quadratics. Just like we graphed lines in the past, we're going to graph quadratics. So here I go. 3p squared minus 17p plus 24 equals 0. Opposite sign of what was over there. Bring it over to the other side. I can't pull out a common factor because 17 is prime, so 17 can't be divided by 3. So I do have to remember when I make my snowflake that that top number is going to contain, or going to be 3 times 24. So 3 times 24 goes on top. I think it's 72. Negative 17 goes on the bottom. I know because the top number is positive, both of these guys are going to have to be negative because the bottom number is negative, top is positive, bottom is negative, so both of them are going to be negative. On the side, it's 3p and 3p. And again, I might have to go and just kind of look at all the options. 1 and 72. Can't get 17. 2 and 36. Can't get 17. 8 and 9. Great. Negative 8, negative 9. One of these sides can be reduced. Looks like the right side this time. P minus 3. If you're unsure how to reduce it, plug it in your calculator, 3 fraction key 9, and then it'll reduce it down to 1/3. And so then you know it's 1p over 3. So when I set these up, 3p minus 8, p minus 3. My 2 equations are 3p minus 8 equals 0, p minus 3 equals 0. The p minus 3 one is super easy. The other one, I have to add 8 two-step equations, divide by 3, leave it as a fraction. It really was just fluke that both of those problems came out to be 8/3. That doesn't, it's not like every time you're going to get an answer that's 8/3. So watch it. I mean, that was just kind of a weird thing that happened. Last one. 10x squared plus 13x minus 30 equals 0. Bring that 30 over. It was positive on the right, so it's negative on the left. Can't factor anything out. When I set up my snowflake, I have to do 10 times negative 30, negative 300. 13 on the bottom. 10x, 10x. It's always the number in front, not squared, regular x. And then I'll have to go through that process again. 300 is 1 and 300. I know one of them has to be negative and one of them has to be positive to get a negative thing, and the bigger one has to be positive to get a positive sum. 1 and 300 doesn't work. 2 and 150 doesn't work. Lucy's very good at this. 25 and 12. Excellent. Remember what I said, that sometimes both of them are going to be able to be reduced. This is one of those cases. On the left, I can divide them both by 5, so that's 2x minus 5. 10 divided by 5 is 2. 25 divided by 5 is 5. On the right, they can both be divided by 2, so that's 5x plus 6. 10 divided by 2 is 5. 10 divided by 2 is 6. I know I did okay if the 2x things that I'm left with, 2x times 5x, should equal 10x squared when you're done. And the bottoms, negative 5 times 6, should equal negative 30 when you're done. So that's kind of a way to check if you want to. But now my two equations are 2x minus 5 and 5x plus 6. So 2x minus 5 equals 0. And 5x plus 6 equals 0. And then I solve. Add 5. Divide by 2. Start to look for patterns and shortcuts. I added the 5. I divided by 2, 5 halves. It's a combination of the two numbers that are there. Same with this one. I'm going to minus 6. Divide by 5. Leave those both as improper fractions. You don't have to do any decimals or plugging in your calculators or anything. And so your homework is going to be just practicing